Now, in this lecture, we find out the area of the blue shape using two different methods. In the drawing, we have a quarter circle. We know that side OB equals to 2 units. We also know that AD equals to DO. Inside the quarter circle, we have a right triangle, triangle DCB, angle DCB equals to 90 degrees. And actually, triangle DCB is inscribed by the quarter circle, and you want to find out the area of the blue triangle, triangle DCB. So we start with the first method. We know that AOB is the quarter circle, therefore angle AOB equals to 90 degrees. This angle equals to 90 degrees. And actually OB is the radius of the quarter circle. That is equal to 2 units. Here OA, point O is the center of the quarter circle, and point A is the point on the quarter circle itself. Therefore, OA is also the radius of the quarter circle. This is equal to 2 units. Okay, so here OA equals to OD. It is the radius of the quarter circle that is equal to 2 units. And we know that AD equals to DO. AD equals to DO. So if we define AD as X, then DO will be also equal to X. So here AD plus DO is X plus X. That is equal to AO, but AO is the radius of the quarter circle that is equal to 2 units. So in conclusion, found out that X plus X equals to AO, that is 2 units. It is the radius of the quarter circle. X plus X is 2X, so 2X equals to 2. We divide this equation by 2, and we get that X equals to 1 unit. So here AD is equal to X, and it is equal to 1 unit, and DO also equals to X, that is equal to 1 unit. And here we will complete the quarter circle to a circle. So we completed the quarter circle to a circle. We'll extend the radius BO by a straight line until it touches the circle. In this point, we define the touching point of the extended BO in the circle as point P. Here, point O is the center of the circle. Point P is the point of the circle itself, therefore PO is the radius of the circle that is equal to 2 units. We extended the straight line PO by a straight line, so PB is a straight line, and PB passes through the center of the quarter circle. Therefore, any chord that passes for the center of the circle must be equal to the diameter of the circle. So PB is at the diameter of the circle. PB is the diameter of the circle. Here we will extend side CD by a straight line until it touches the circle. So we created here peripheral angle. This is a peripheral angle, and this peripheral angle equals to 90 degrees. But we have the rule that any peripheral angle that equals to 90 degrees must rest on the diameter of the circle. Therefore, this peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. That is to say, the extended side CD must pass through point P. Why? Because this angle BCP that is equal to 90 degrees must rest on the diameter of the circle that is PB. Therefore, CD passes through point P. In this way, we get that this angle that is equal to 90 degrees passes rests on the diameter of the circle that is PB. Okay. In the next step, we will extend line segment AO by straight line until it touches the circle. At this point, we define the touching point of the extended line segment AO and the circle as point Q. Point O is the center of the circle, point Q is the point of the circle itself. This is exactly the definition of a radius. So OQ is the radius of the circle that is equal to 2 units. Okay? Here we will focus on the right triangle POD. On the right triangle POD, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle POD, by PT is the relation for Pythagoras theorem. The square of the hypotenuse is PD square, and it must be equal to d all square plus p all square. I'll repeat again. In the right triangle POD, according to the Pythagoras theorem, PD square equals to p all square plus p all square. So PD square equals to d all square, d all equals to 1, so d all square is 1 square, that is 1, plus p all square. P all equals to 2, so p all square is 2 square, that is 4. So in conclusion, we found out that p all square equals to 1 plus 4, that is 5. Here we take out of this equation and we get that PO equals to the square root of 5 units. So we found out that PO equals to the square root of 5 units. In the next step, we will focus on the right triangle DOB, this right triangle. In the right triangle DOB, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is dB, so the square of the hypotenuse is dB square. It is equal to dC square plus CB square. Actually, we'll focus on the right triangle ODB. In the right triangle ODB, this right triangle, the hypotenuse is dB, therefore the square of the hypotenuse is dB square, and it must be equal to d all square plus OB square. Repeat again, in the right triangle, triangle DOB, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, dB square equals to d all square plus OB square. So dB square equals to d all square. d all equals to 1, so d all square is 1 squared, that is 1, plus OB square. OB is 2, so OB square is 2 squared, that is 4. So in conclusion, we found out that dB square equals to 1 plus 4, that is 5. We take out of this equation and we get that dB equals to the square root of 5 units. dB equals to the square root of 5 units. Here. In the next step, I will present to you a rule that is related to two chords that intersect with each other inside the chord, inside the circle, and we'll implement the new rule, the rule that is not a new rule in our drawing. So here it will be rule number 1. According to rule number 1, if we have this circle, inside this circle we have chord AB. This is chord AB. It intersects with chord CD. This is chord CD. It's point O. Point O is the intersection point of chord AB with chord CD. So if this is the data that has been given to us, then the following equation is true. That AO times OB equals to CO times OD. I'll repeat again on rule number 1. According to rule number 1, if chord AB intersects with chord CD at point O is the intersection point of chord AB with chord CD, then AO times OB equals to CO times OD. Okay? So here, AO, so we'll implement rule number 1 in our drawing. In our drawing, we have chord AQ that intersects with chord PC at point D. Again, chord AQ intersects with chord PC at point D. I will write it down. Chord AQ intersects with chord PC at point D. Point D is the intersection point of chord AQ with chord PC. I'll repeat again. Chord AQ intersects with chord PC at point D, therefore according to rule number 1, we'll get that AD times DQ, AD times DQ equals to PD times DC. I'll repeat again. Now drawing according to rule number 1, we get that AD times DQ equals to PD times DC. So here AD equals to 1 unit, DC equals to 1 plus 2, that is 3. And it is equal to PD. PD is square of 5 units times DC. DC is the missing 9 segment. So in conclusion, we found out that 3 equals to square root of 5 times DC. Here we will divide this equation by square root of 5, and we'll get that DC equals to 3 over square root of 5 units. Okay? So here we found out that DC equals to 3 over square root of 5 units. Okay? So in the next step we will focus on the blue right triangle, triangle DCB. We will implement triangle DCB. We will implement the Pythagoras theorem on the right blue triangle, triangle DCB. In the right blue triangle, triangle DCB, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the slopes of the perpendiculars. The hypotenuse is dB, so the square of the hypotenuse is dB square, and it must be equal to the sum of the slopes of the perpendiculars. That is to say, it must be equal to dC square plus CB square. I will repeat again. In the right triangle, triangle DCB, according to the Pythagoras theorem, dB square equals to dC square plus CB square. So dB is square root of 5, so dB square is square root of 5 square, that is 5, and it is equal to 3 dC square. dC is 3 over square root of 5, so dC square is 3 over square root of 5 square, that is 9 over 5, plus CB square. CB is the 9 segment. So in conclusion, we found out that 5 equals to 9 over 5 plus CB square. Here we subtract 9/5 from this equation, and we get that 5 minus 9/5 equals to CB square. Here we multiply 5 by 5, and then we divide it by 5 in order to have a common factor of this expression. So 5 times 5 is 25. 25 minus 9 over 5 equals to CB square. Twenty-five minus 9 is 16, and 16 over 5 equals to CB square. So here we take a root out of this equation, and we'll get that CB equals to the square root of 16 is 4 over square root of 5. So in conclusion, we found out that CB equals to 4 over square root of 5. So we can write here that CB equals to 4 over square root of 5. Now it is very easy to find out the area of the green of the blue right triangle DCB. The area of triangle DCB will be equal to the base of the triangle, that is DC, times the height to the base, that is CB, over 2. So the area of the blue triangle DCB equals to the base of the triangle, that is DC, times the height to the base, that is CB, over 2. So DC equals to 3 over square root of 5 units. CB equals to 4 times square root of 5 units, all divided by 2. I repeat again, DC equals to 3 over square root of 5 units, CB equals to 4 over square root of 5 units, all divided by 2. So here, 3 times 4 is 12, over square root of 5 times square root of 5 is 5, and here we have also 2. So 12 over 2 is 6, so in the denominator we have 6, and in the denominator what is left is 5. So in conclusion, we found out that the area of this blue right triangle DCB equals to either 6 over 5 square units, so in terms of numbers it is equal to 1.2 square units. So we finish with the first method. In the next step, I will present to you the second method. Because of the fact that AOB is a quarter circle, angle AOB equals to 90 degrees, and AO equals to OB, it is the radius of the quarter circle, that is equal to 2 units. We have already found out that AD equals to 1, therefore the O will be also equal to 1. In the next step, we will complete the quarter circle to a circle. And we will extend BO by a straight line until it touches the semicircle. At this point, we define the touching point of the extended BO and the semicircle is P, point P. O is the center of the semicircle and also the quarter circle, and P is the point of the semicircle itself. This is exactly the definition for radius. So PO is the radius of the semicircle, that is equal to 2 units. Actually here PB is this chord PB passes through the center of the semicircle, therefore chord PB equals, it is the diameter of the semicircle, and any chord that passes through the center of the circle or semicircle must be the diameter, so PB passes through point O, therefore it must be the diameter. Actually, PB is a straight line because we extended the radius BO by straight line, and when you extend a straight line by straight line, the result must be a straight line. So PB is a straight line that is equal to the diameter of the semicircle. Here we'll extend side DC until it touches the circle at this point P. Actually, here we've already explained in the first method that this angle BCP must, or the extended line segment CD must pass for point P. But I will explain again that here, by extending side CD until it touches the circle at any point, we created a peripheral angle. But this peripheral angle equals to 90 degrees. And we have the rule that any peripheral angle that equals to 90 degrees must rest on the diameter of the circle. That is to say, the extended line segment CD or side CD must pass for point P. That is, in this way, we get that this angle that is equal to 90 degrees rests on PB, that is the diameter of the circle, according to the rule that any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. And because of the fact that this is a right angle, or this peripheral angle is a right angle, therefore it must rest on PB, that is the diameter of the semicircle. Therefore, P, the extended side CD, must touch side P, or must pass for side P. Okay? So here, PB is the diameter of the circle, and therefore it is absolutely a straight line. And we know that the sum of the angles on one side of a straight line equals to 180 degrees. So if we focus on the upper side of the straight line PB at point O, then the sum of the angles here must be equal to 180 degrees. So this angle equals to 90 degrees, plus this angle, in total they must be equal to 180 degrees. Therefore this angle must be equal to 90 degrees in order to complete the sum of the angles on the upper side of the straight line P at point O to 180 degrees. This angle must be equal to 90 degrees. Okay, we have already proved it on the first method, but now I repeated on it. So here we have triangle POD is a right triangle. We implemented the Pythagoras theorem of the right triangle POD in the first method, and we found out that PD equals to a square root of 5 units. We implemented the Pythagoras theorem on the right triangle DOB in the first method, and we found out that the hypotenuse DB equals to square root of 5 units also. And here we define angle DPO as theta. If angle DPO equals to theta, then angle PDO, this angle, must be equal to 90 degrees minus theta. In order to complete the sum of the angles in this right triangle POD to 180 degrees, this angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus 90 degrees is 90 degrees, and 90 degrees, 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 120 degrees. Likewise, in the big right triangle, triangle BCB, this angle equals to theta. This angle equals to 90 degrees. This angle equals to 90 degrees. This is the right angle. So this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in the right big triangle, triangle BCB to 180 degrees. This angle must be equal to 90 degrees minus theta. Okay, so in the next step we'll prove that the small right triangle PDO is similar to the big right triangle, triangle PCB. Okay, I'll write it down. We prove that the small right triangle POD is similar to the right triangle, triangle PCB. So, why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So this is angle DOP. That is equal to this angle that is actually angle PCB, and they are both equal to 90 degrees, therefore they are equal to each other. Repeat again, angle DOP equals to angle PCB, and they are both equal to 90 degrees, therefore they are equal to each other. In addition, here, this angle is a common angle, it belongs to both angles, so this angle equals to itself, or we can write down that angle DOPD equals to angle CPB and this angle equals to theta. So here, angle OPD equals to angle CPB, that is equal to theta. It is a common angle that belongs to both triangles. And finally, we have those two angles that are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle POD is equal to angle PBC and they are both equal to 90 degrees minus theta. Repeat again, angle POD equals to angle PBC, they are both equal to 90 degrees minus theta. So we actually proved that all three angles of triangle POD can go into all three angles of triangle BCB. Therefore, triangle POD is similar, this is the sign of similar, to triangle PBC according to angle similarity rule. Okay, and from the fact that the two right triangles are similar to each other, we conclude that the following relationship exists between their sides. We conclude that PD over PB equals to DO over CB, and it is equal to PO over PC. I repeat again, from the fact that the two right triangles are similar to each other, we conclude that PO over PB equals to DO over CB equals to PO over PC. Okay? PD equals to the square root of 5 units. Over PB equals to 2 plus 2, that is 4, and it is equal to DO equals to 1 unit, over CB. CB is the infinite segment, so we leave it as it is, and it is equal to PO equals to 2 over PC. PC equals to square root of 5 plus DC. Square root of 5 plus DC. So in conclusion, we found out that square root of 5 over 4 equals to 1 over CB, that is equal to 2 over square root of 5 plus DC. We derive the first equation those two expressions are equal to each other, so here this will be equation number 1, the square root of 5 over 4 equals to 1 over CB. Here we will multiply this equation by CB, and we get that square root of 5 times CB over 4 equals to 1. We'll multiply this equation by 4, and we'll get that square root of 5 times CB equals to 4. Here we'll divide this equation by square root of 5, and we get that CB equals to 4 over square root of 5. So we found out here that CB equals to 4 over square root of 5. In the next step, we will derive the second equation from this big expression. We'll compare the first column and the third column, that is to say, the square root of 5 over 4 equals to 2 times square root of 5 plus DC. Here we'll cross multiply this equation, and we get that square root of 5 times square root of 5 plus DC equals to 4 times 2 is 8. We will open the brackets on this side of the equation, and we get that square root of 5 times square root of 5 is 5. That is equal to square root of 5 plus square root of 5 times DC, that is equal to 8. Here we will subtract 5 from this equation, and we will get that square root of 5 times DC equals to 3. We divide this equation by square root of 5, and we get that DC equals to 3 over square root of 5 units. Okay, here DC equals to 3 over square root of 5 units. Now it is very easy to find out the area of the blue right triangle. It will be equal to the base of the triangle, that is DC, times the height of the base, that is CB, over 2. So the area of triangle DCB be equal to DC, that is the base, times CB, that is the height of the base, over 2. I'll repeat again. The area of the right triangle DCB, the right blue triangle, will be equal to the base of the triangle, that is DC, times the height of the base, that is CB, over 2. Here DC equals to 3 over square root of 5, times CB is 4 over square root of 5, all divided by 2. Okay. So here we found out that the area of triangle DCB equals to 3 over square root of 5 times 4 over square root of 5 times 2. Here 3 times 4 is 12, over square root of 5 times square root of 5 is 5, and times 2. Here 12 times 2 is 6, so it is 6 over 5. So we found out that the area of the blue right triangle DCB equals to either 6 over 5 square units, or in terms of numbers, is equal to 1.2 square units. Okay. In the next step, I will summarize the lecture. We'll start in the first method. So actually, in the drawing we have a quarter circle A or B. Inside the quarter circle A or B we have the right triangle that is inscribed by the quarter circle. Side OB equals to 2 units, AO equals to ODO, and again DOCB equals to 90 degrees, and we want to find out the area of the blue triangle, the right triangle, OCB. So first of all, we know that AOB is a quarter circle, therefore this angle AOB equals to 90 degrees, and OB is the radius of the quarter circle that is equal to 2 units, and it is also equals to AO, that is also the radius. Okay. Then we defined AD as x, therefore the O will be also equal to x. So here AD plus DO equals to AO, or x plus x equals to AO. X plus x equals to AO, but AO equals to 2 because it is the radius of the quarter circle. So AO equals to 2. So 2x equals to 2, we divided this equation by 2 and we got that x equals to 1. So here AD is equal to x equals to 1, and DO that is also equals to x also equals to 1. Okay. Then we actually completed the quarter circle to a circle, and then we extended side CD by a straight line until it touches the circle at any point. In this way we created a peripheral angle that is equal to 90 degrees, and any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. That is to say, CD will touch, the extended CD will touch point P. Okay, because of the fact that peripheral angle, this peripheral angle equals to 90 degrees, it must rest on the diameter that is PB, therefore the extended CD must touch point P. Okay? According to the rule that any peripheral angle that is equal to 90 degrees rests on the diameter. And therefore it rests on the diameter that is PB, it means that it touches point P. Extended CD touches point P. Then we actually have here we know that chord PB passes through the center of the circle, therefore, because of the fact that it passes through the center of the circle, it must be the diameter of the circle. So PB is the diameter of the circle, therefore it is absolutely a straight line, and we know that the sum of the angles on one side of a straight line equals to 180 degrees. So if you focus on the upper side of the straight line PB at point O, then the sum of the angles here must be equal to 180 degrees. So this angle equals to 90 degrees. This angle must be also equal to 90 degrees in order to complete the sum of the angles at point O and the upper side of PB to 180 degrees. This angle must be also equal to 90 degrees. Okay, so this is a right angle. Then we implemented the Pythagoras theorem on the right triangle POD. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is PD, therefore the square of the hypotenuse is PD squared. That it must be equal to OD squared plus PO squared. Repeat again. PD squared, according to the Pythagoras theorem, PD squared must be equal to OD squared plus PO squared. OD is 1, so OD squared is 1 squared, that is 1, plus PO squared. PO is 2, so PO squared is 4. 2 squared is 4. If we conclude and found out that PO squared equals to 1 plus 4, that is 5. We took out of this equation and found out that PO equals to a square root of 5 units. PO equals to a square root of 5 units. Then we focused on the right triangle BOC, triangle DOB, on the right triangle DOB. On the right triangle DOB, according to the Pythagoras theorem, we get that OB square, DB square equals to DO square plus OB square. DB square equals to DO square plus OB square. So DB square equals to DO square. DO is 1, so DO square is 1 square, that is 1, plus OB square. OB equals to 2, so OB square is 2 square, that is 4. So in conclusion, we found out that DB square equals to 1 plus 4, that is 5. We took out of this equation and we found out that DB equals to square root of 5 units. Here DB equals to a square root of 5 units. And then I presented to you rule number 1 and we implemented rule number 1 in our drawing. Actually here we extended the radius AO by a straight line until it touches the circle at point Q. Point O is the center of the circle, point Q is the point of the circle itself, therefore OQ is the radius of the circle that is equal to 2 units. Okay, then we implemented rule number 1 in our drawing. What is rule number 1? Rule number 1 states that if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. Actually, we can implement rule number 1 in our drawing. Why? Because in our drawing we have chord AQ that intersects with chord PC at point D. Okay? Chord AQ intersects with chord PC at point D. Therefore, according to rule number 1, we get that AD times DQ equals to PD times DC. AD times DQ equals to PD times DC. According to rule number 1, of course. AD is 1. DQ is 1 plus 2, that is 3. And it is equal to PD. PD is equal to 5 units times DC. Here, DC is the missing line segment. So in conclusion, we found out that 3 equals to square root of 5 times DC. We divided this equation by square root of 5 and found out that DC equals to 3 over square root of 5 units. Okay, here, DC equals to 3 over square root of 5 units. Then we implemented the Pythagoras theorem on the right triangle, the right blue triangle, triangle DCB. This is the area of the triangle that we are looking for. That is the area of the blue right triangle, triangle DCB. We implemented the Pythagoras theorem on the right blue triangle, triangle DCB. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, dB square equals to DC square plus CB square. Repeat again. The right triangle, the right blue triangle, triangle DCB, dB square equals to DC square plus CB square. dB equals to square root of 5 units, so dB square is square root of 5 units squared, that is 5, plus DC square. D is 3 over square root of 5, so DC square is 9 over 5, plus CB square. Here we subtracted 9 over 5 from this equation and found out that 5 minus 9 fifths equals to CB square. We multiplied 5 by 5 and then we divided it by 5 in order to have a common factor with this expression. And found out that 25 minus 9 over 5 equals to CB square. 25 minus 9 is 16, so in conclusion we found out that CB square equals to 16 over 5. We took all of this equation and found out that CB equals to the square root of 16, that is 4, over square root of 5. So in conclusion we found out that CB equals to 4 over square root of 5. Okay, now it is very easy to see, to find out the area of the blue right triangle, triangle DCB. It will be equal to the base of the triangle, that is DC, times the height to the base, that is CB, over 2. Again, the area of triangle DBCB, the area of the blue right triangle, triangle DCB equals to the base, that is DC, times the height to the base, that is CB, over 2. DC equals to 3 over square root of 5 units. CB equals to 4 over square root of 5, all divided by 2. So here 3 times 4 is 12, and here we have square root of 5 times square root of 5 is 5, times 2. 12 over 2 is 6, so in the numerator we left only with 6, in the denominator we have 5. So in conclusion we found out that the area of this blue right triangle, triangle DCB equals to either 6 over 5 square units, or in terms of numbers it is equal to 1.2 square units. We finished with the first method, then I presented to you the second method. In the second method, here you know that this is a contour circle, a oblique contour circle, therefore this angle equals to 90 degrees. OB is the radius, that is 2 units. AO is also the radius, that is 2 units. We have only found out in the first method that AD equals to 1 and DB also equals to 1. And then here we completed the quarter circle to a semicircle, and then we extended side CD until it touches the circle, and because of the fact that we created here a peripheral angle that is equal to 90 degrees, it must rest on the diameter. That is to say, the extended CD must pass for point P, because of the fact that this peripheral angle equals to 90 degrees, and any peripheral angle that is equal to 90 degrees must rest on the diameter, and the diameter is PB. Therefore, it must touch, the extended CD must touch point P. Okay? Then, according to the first method, we already found out that PO equals to square root of 5 units, and we already found out that OB equals to square root of 5 units. Okay? Then, according to the first method, this is a right angle. We define this angle as theta, therefore this angle must be equal to 90 degrees minus theta, and this angle must be also equal to 90 degrees minus theta in order to complete the sum of the angles in the right angle to 180 degrees. This angle must be equal to 90 degrees minus theta. Then we proved that the right big triangle, triangle PCB, is similar to the right small triangle, triangle POD. Why those two triangles are similar to each other? First of all, we have those two angles, they are both right angles, therefore they are equal to each other. This angle theta is a common angle that belongs to both triangles, so this angle equals to itself, and those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we prove that all the angles of triangle A or B can go to all the angles of triangle POD, therefore those two triangles are similar to each other according to angle similarity rule. Triangle POD similar to triangle BBC according to angle similarity rule. And from the fact that those two triangles are similar to each other, we derive that PD over PB equals to DC over CB equals to PO over PC. PD is equal to 5 units, PB is 4, here PB, 2 plus 2 is 4, so PB is 4, DO is 1, CB is the missing line segment, PO is 2, and PC equals to square root of 5 plus DC. PC equals to square root of 5 plus DC. So, from this long equation, we derive this equation, that square root of 5 over 4 equals to 1 over CB. We multiplied this equation by CB and found out that CB times square root of 5 over 4 equals to 1. We multiplied this equation by 4 and found out that square root of 5 times CB equals to 4. We divided this equation by square root of 5 and found out that CB equals to 4 over square root of 5. Here, CB equals to 4 over square root of 5 units. Okay? Then, here, the third column is equal to the first column is equal to the third column. We create it in this way. The second equation, that 4 square root of 5 over 4 equals to 2 over square root of 5 plus DC. We multiplied, because multiplied this equation, and we found out that 4 times 2 is 8, and it is equal to square root of 5 times square root of 5 plus DC. We opened the brackets on this side of the equation and found out that square root of 5 times square root of 5 is 5. And square root of 5 times DC is square root of 5 DC. So in conclusion, we found out that 5 plus square root of 5 DC equals to 8. We subtracted 5 from this equation and found out that square root of 5 DC equals to 8 over 8 minus 5 is 3. So square root of 5 times DC equals to 3. We divided this equation by square root of 5 and found out that DC equals to 3 over square root of 5. Here, DC equals to 3 over square root of 5. So now it is very easy to calculate the area of the blue right triangle DCB. The area of this blue triangle equals to the base that is DC times the height to the base that is CB over 2. Repeat again. The area of the blue triangle DCB equals to the base that is DC times the height to the base that is CB over 2. DC equals to 3 over square root of 5 units, CB equals to 4 over square root of 5, all divided by 2. So in the numerator we have 3 times 4 is 12. In the denominator we have square root of 5 times square root of 5 is 5, so it is 5 times 2. Here 12 over 2 is 6, so in the numerator we have 6, in the denominator we have 5. So in conclusion, we found out that the area of the blue triangle DCB, the area of this triangle, equals to either 6 over 5 square units, or in terms of numbers, it is equal to 1.2 square units. Okay, so in both methods, we arrive to the same result. Okay, thank you very much.